Hello to everybody. I'm really happy to greet all the participants of the International Conference on Science and Technology Research held in London on 10th, 11th of December 2020. My name is Lyudmila Gryzun. The topic of my keynote presentation is Mobile Technology for Petri Nets Mastery. I'd like to represent my affiliation, the National University of Economics from Kharkiv City, Ukraine, where I currently work as a full professor of Information Systems Department. I earned my master's degree in applied mathematics from the State University of Kharkiv City, Ukraine. I also earned PhD and second doctoral degree in pedagogical sciences, and the sphere of my scientific research covers some spheres, which you can see on the screen. Here you can see my recent successful projects, among which there are keynote presentations at the Eurasia Research International Conferences, where I took part in last 2 years. The focus of my current scientific activity is holistic educational approach to different specialist training. In the context of the holistic approach, the modeling and simulation activities in the process of students' training play increasingly special role. And my presentation covers some recent exploration in this area. Today, I'm going to cover some issues connected with Petri Nets as a modeling instruments. Then I'd like to represent the development of mobile application, Petri Nets Tool-Kit, which was undertaken in my department, and modeling activities within its environment. I also want to get you familiar with the results of our research and some of the prospects. The models and simulations have always been in focus of different specialist training and have become integral part of an advanced learning environment. According to studies, modeling activities must be incorporated into the training process due to their high didactic potential. It is emphasized the essential role of computer models, building and simulation. In particular, the computer simulation provides facilities of dynamic visualization and modification of the model, which allows students understand deeper the basic features of the model processes and develop their investigative intuition. Computer simulations are also seen as an opportunity to explore complex processes without having access to their real prototypes and to understand the peculiarities of interaction of its different elements. In the context of computer or digital models, building and simulation, nowadays priorities tend to shift in the favor of mobile aids using on learning purposes. It is explained by the rapid growth of across the curriculum mobile gadgets use, BYOD strategy spreading in all levels of education, current needs for integration of different educational technologies, flexible forms of learning, and tools for students' personal independent work. In the studies, it is pointed out some common features of mobile learning which seem to be beneficial for computer simulation mastering by the students. Opportunity to study always and everywhere, provoking trainees to generate and test their own ideas instantly, portability of devices and immediate availability of learning mobile aids, facilities to easy content renewing and sharing the results of your work within the mobile applications. All of these features make mobile learning really attractive for young generation. There are some quite well-known mechanisms and tools of mobile modeling and simulation that has been used efficiently for relevant investigation practice. Among them, there is Petri Nets theory, which has found its wide application to the real-life parallel process modeling. Petri Nets give powerful facilities for dynamic models building and enable comprehensive learning of the process peculiarity. Hence, it is important to have relevant digital tools which allow to apply Petri Net's potential to educational practice on purpose of developing students' skills of models building and investigation. In addition, regarding the contemporary tendencies in favor of mobile learning, it seems to be essential to develop and implement a mobile application with necessary tools and content. However, the analysis of the available software testifies the lack of proper aids which could satisfy the needs of Petri Nets using on educational purpose of modeling skills earned by students, and exactly in terms of mobile learning. In particular, the analysis of the existing environments testify that all of them are mostly web-oriented software which are internet dependent, so they cannot be equally used by all students and everywhere. Some of the current applications are desktop ones and hence are not usable on the purpose of mobile learning. Some of software provide a user with necessary tools for Petri Nets design and analysis, but they represent just a toolkit, which is empty, and it doesn't provide proper didactic support for a student, which definitely decreases the educational value. Thus, current important and research aim of the work include elaboration of an aid which is able to provide mobile learning for students modeling based on Petri nets, created means and specifying examples of its using for mastering modeling by students in terms of their professional training, and learning the impact of the trainees' level of modeling skills and cognitive eagerness in terms of research prospects. Developing the application, we address to the fundamentals of Petri Nets theory, and we applied some research methods which cover theoretical, empirical, modeling methods, which were applied to our during our research. We addressed definitely to the fundamentals of Petri net theory, which provided us the mathematical basics of the net building and their application to the process modeling. Petri nets make a modeling formalism with a graphical representation and a precise syntax and semantics. According to theory, a Petri net can be defined as a two-partite oriented graph which includes two types of vertices in particular places, which are designed as circles, and transitions, which designed as bars. Also, there is so-called R component, which determines a relationship between the vertices corresponding to the arcs, the places, also circles, they can accommodate tokens that can move around the net via transitions, and in such a way, number of tokens and their disposition and around the net control the net execution and imitate dynamic of the process. The main features of Petri nets demonstrate their core advantages to be effectively used for modeling of parallel and consequent process. In educational context, we would like to emphasize some essential Petri nets benefits. The formalism has intuitively clear means corresponding to real objects, events, and their interaction, which facilitates building of the real processes model. Also, demonstration allows demonstration of the interaction of the process components in its dynamics, visualized in computer interpretation of the net. Also, it gives facilities of manipulation with the net's parameters and changing its state with immediate visualization. All of these things make Petri Nets powerful instrument for students learning to model and simulate processes during their training. Um, the basics of Petri Net theory and their educational benefits were applied by the authors to development of the mobile application Petri Nets Tool-Kit. The requirements to the applications were determined, which determined its functionality, were formulated due to the didactic needs as for the incorporation of mobile modeling activity into the students' training. And in terms of the requirements, it became clear that our application has to provide a trainee with the necessary tools to build a Petri net as a model of a process, to validate its functionality, to manipulate with its parameters, to edit and save the built Petri net. Then it should provide the trainee with ready-made examples of Petri nets with learning tasks to explore the net's behavior and to use them as a base for trainees' own models, and with concise theoretical materials on Petri nets formalism. In terms of technical needs, it must be running on all Android operation systems since version 5, and the net overload should not exceed 300 milliseconds. Coming from the formulated requirements, the main phases of the application development were outlined. At the first stage, the didactic functions of the application were specified due to the requirements, which made the basis for um, interface specifications. At the next stage of the general architecture of the application was developed. It defined the core structure of the application, links between the components which were determined by the basics of application functions. In particular, the general architecture is represented by two main components, data component, which allows to store Petri net and to manipulate with it, and graphical support component, which allows to demonstrate the modeled process using graphical narratives. Then object-oriented analysis and design were provided. In the process of the analysis, the technical functions of the application were determined in terms of concepts and objects of the subject domain, based on the depicted concepts and revealed links between them. The use case diagram was built at this stage to describe in details and potential users' behavior. In particular, it was determined that the user is expected to initiate the set of use cases, something like to run the application, to get familiar with Petri Net's basics, to work with ready-made examples of the net, to design their own Petri net, and so on. As a result, the conceptual model of the subject domain process modeling by the means of Petri nets was created. At the next phase, the application interface design was undertaken. Then it was the stage of the program realization of the application Petri Nets Tool-Kit in Java within Android Studio platform, during which case diagram was built and the class and method description was done, along with the program and implementation. At the next stage, the necessary didactic component and didactic content for the aid was created, and proper components were filled in with the theoretical material, Petri Nets examples, learning tasks, instructions, etc. The final stages were devoted to the application testing and introduction, implementation it into the practice of the students' classroom and independent learning activities. Characterizing the Didactic potential of Android application Petri Nets Tool-Kit as for the student modeling activity. Uh, we would like to recommend some stages of learning activity for step-by-step mastering by students the basics of modeling and simulation based on Petri Nets formalism. Below, we are illustrating the learning activity on some examples of modeling problems within the environment of our application that we offer to the students within their classroom and independent mobile learning. In particular, we would recommend to start with the work in the some modes of our application. The first mode is Petri Nets design. The second mode, the exploring examples library, and the mode number three, that is learning fundamentals of Petri Nets theory. Actually, we would recommend to start with the work exactly in the third mode, yeah, with a special kind of activity. It's so-called serial learning enhanced with the work upon simple samples provided by the examples library. For instance, at this stage, a trainee can be proposed to model the traffic control with the traffic lights using a simple net from the library. Here, students are asked to determine which places refer to the traffic lights, what functions of transitions are. Then students are encouraged to add independently proper places and transitions in order to simulate triggering of traffic movement, to set up initial marking and execute the net. Here you can see some episodes of students learning activity upon the sample, and using the slider, students can change initial marking of the net and explore the states of the net. Episodes of modeling activity are shown on the screen. At the next stage of learning activity, students can be offered to solve independently some simple modeling problems. Um, in the context of training of students of various specialities, it is beneficial to learn how to model the process of mass service on the example of colloquium exam passing or some colloquial interview. The problem may be formulated in such a way to build a model of passing an exam by four students to a teacher. In order to solve such a problem and to design proper net, the trainees have to detect themselves how many places and transitions they will need, how to join them, what the role of the initial marking is, etc. Students design the net using the instruments of our mobile toolkit. Afterwards, trainees are asked to imitate different scenarios over the given process. For example, when all four students are waiting for their turn, for the situation when two students are waiting and one student is passing his exam, so the teacher is busy and unavailable to other students, and other situations. Various scenarios of the evolution of the process of passing a colloquial exam are here on the screen. Also, it is beneficial to offer students um, uh, the third type of activity in order to advance students' modeling skills. We would recommend them to solve more complicated real-life problems. For instance, it might be the problem as for simulation of safe one-way movement on the railway segment of the given configuration, which you can see on the screen, which consists of arrival drives with semaphores and indicators of occupation. To provide effective modeling and simulation activity, it is relevant to encourage trainees to analyze the given configuration of the road and to determine the purpose of places and transitions they need, how to join them to obtain the necessary shape of the road, what kind of initial marking to assign, etc. The results of the model building on its different stages are given on the picture, and after the model building itself, it is recommended to offer students to imitate and investigate various scenarios of the process, emphasizing the conditions of safe movement for this exact segment of the railway. Thus, depicted above functionality of mobile application Petri Nets Tool-Kit and examples of modeling activities in its environment testified its significant facilities as for earning simulation habits and investigative skills for students of various specialties like technical, engineering, IT, sphere, and so on, within the set of curriculum subjects such as discrete mathematics, computer modeling, programming, and others. In fact, simulation activities simulation activities provided by the application are able to awake students' interest as for process exploring, imitating their different scenarios, their critical estimation, and revealing their weak points. In such a way, these activities within the application encourage students to inquiry-based learning and develop their modeling and investigative skills. We'd like also to underline some special benefits of the application using in training of exactly pre-service teachers, especially science, mathematics, and informatics teachers. In fact, modeling activities based on Petri Nets formalism within our mobile toolkit arm the potential teachers with powerful tool of various processes simulation and exploring. In learn and run, it can be extended by the pre-service teachers in their own training activity with school children. In addition, using Petri Net tools, teachers can incorporate the elements of gamification into the learning processes. Special emphasis should be put on the advantages of exactly mobile learning of Petri Nets modeling provided by the 8 Petri Nets Toolkit. In particular, it supplies a trainee with all necessary theoretical, didactical, and instrumental means to design and to explore a process model easily and in thought-provoking way. The application can be downloaded to an Android device, so it is internet independent and can be used completely everywhere and free. In addition, a student is enabled and encouraged to fill up the example library with his own Petri Nets models to use them for further elaboration and exploration. It makes the application an attractive tool for individually driven mobile learning, which motivates a student to master modeling skills according to his personal interests and needs. On the whole, the Android mobile application Petri Nets Toolkit represents a portable convenient tool for instant and permanent model design, experimenting, hypothesis testing, provoking students to improve their modeling and investigative skills anywhere during the day. So the application has been developed on its pilot version with the set of functions presented above. It was implemented into the pre-service teachers training for the first time within the classroom and independent work on the courses of computer modeling, discrete mathematics, and programming. Empirical research as for the impact of modeling activity in the elaborated application Petri Nets Toolkit is ready to get started, and criteria basis and mechanisms is developed. Due to the results of the future empirical research, the application will be elaborated. Summing up our research, I'd like to emphasize that it is depicted the functionality of the mobile application Petri Nets Toolkit developed by the authors in the measures of our department. The basic stages of application development are covered. The examples of the application using to provide modeling activities for students within their mobile learning are specified. The advantages and benefits of process modeling provided by the application are emphasized in the context of students' vocational training in terms of different specialities. The proper stages of learning activity for step-by-step mastering by students, the basics of modeling and simulation are disclosed, and the prospects of the work are outlined in terms of the empirical researches for validating the impact of modeling activity in the elaborated application on the trainees' level of modeling skills. Thank you for your attention. I'm ready to answer your questions.